Hello everyone. Today we are going to discuss one algorithm, string algorithm, Z algorithm, and we will solve one problem from CSES problem set with the help of this algorithm. So let's jump into this algorithm. So this is called Z function. So what Z function does, let me explain it to in with an example. So let's say we have some string ABC, and let's say we have some string ABC. So z function means that z of I means that what is the length of the prefix starting from index I which is matching. Okay. So let's say for this index, okay, for this index, what is the length of the prefix? It is matching. So length of the prefix, let's say this is the entire string. So this particular string has a length of 3 which is matching it with prefix 3. Okay, so z of I will be 3 here. Okay, so z of I will be 0 here, 0 here, 0 here, and 3 here, and 0 here again, and 0 here again. Okay, so what zi means, I hope you understood that the from starting from index I, what is the length of the string which is matching with the prefix. So we can say that s of 0 to zi, 0 to zi will match with s of I to I plus zi. This thing is important, that s of 0 to zi is equals to s of I to I plus zi. Okay. Now let's jump into the problem, and we will also discuss how this zi will be calculated. But first, let's understand what the problem is and how we can use the zi to solve this problem. So let's jump into the problem. So this is a quite simple problem, that we are given a string and a pattern. Our task is to find the count of the number of position where the pattern occurs in the string. So if we take this example, so let me copy it here in the page. So this means that we have to find the number of occurrences of pp in this string. So this is the text and this is the pattern. So how many positions pp occurs? Pp occurs here and pp occurs here. So the number of occurrences in the given text for the pattern is 2. So our answer will be 2. Let's check. Yes, the answer is 2. So how we can use this zi or z function to solve this problem? Okay. So the brute force algorithm will be, if the length of this string is n and length of this string is m, then the brute force solution is obviously order of n into m. Okay, order of n into m, where we check every substring of length m. We will check every substring of length m with this pp, with this substring pp. Okay. So what is this algorithm? Let me discuss the brute force algorithm again. So we'll take every substring of length 2 from the text. So the first substring is SA. So we'll try to match SA with PP. Similarly, we'll do for AI, and we'll do for IP, and we'll do for PP, like that. We'll take every substring of length 2 and compare it with the given pattern. So we'll get the desired answer. But the overall time complexity will be order of n into m. So this problem is also solvable using string hashing. So instead of taking the string, storing the string and compare it with pp, we can take the hash of this length through substrings and take the hash of this pattern and check if the hashes are equal or not. So string hashing is also can be used to solve this problem, but I will discuss the string hashing in some of my other video. But for this example, or for this problem, let's understand is using our z algorithm. So let's try to compute this for this string z algorithm for this string. So let's only take the first 5 characters, because I don't want to calculate for every character in this long string. It will take very much time. Okay, so we will not compute this string value for the entire string. Okay, we have to somehow modify the string. Okay, so let's say our text is say IPP and our pattern is PP. So what we will do, we will create one new string. We will create one new string by with t plus, let's say we have taken some special character. Let's say here we had taken dollar, t plus dollar plus p. So what will be our resultant string? Our resultant string will be nothing but say I p. Sorry, we have to take the reverse. Actually, not t plus dollar plus p. We have to take p plus dollar plus t. I will explain why. So we have to take P plus dollar plus T. Then it will be PP dollar and SAIPP. Okay. Now let's compute the value of zi for each and every value. So this is z of 0 will obviously be 0. Now this is matching with this p. Okay, this is matching with this p. So z one value will be 1. So I have already explained what zi is. Let me repeat again. So zi means that starting from index I. So this is exactly what is zi. So s of 0 to zi should match with s of I to zi. Among all the values of this value zi should be maximum. So here you can check that if we take length string of length 1, this is matching. Okay, so it will be 0 1 0. Here it will be again 0. Here it will be again 0. Here it will be again 0. Here it will be 2, and here it will be 1. So what we have to check for all the computed z values, we have to check in which positions zi value is greater than equals to length of the pattern, or we can say length of p. Okay, if zi greater than equals to length of p, then we can definitely say that this is one of our index. So why I am taking zi greater than equals to p instead of zi equals to p? Let's take t as ppp. Okay, let's take t as ppp. In that case, our p plus this string will be nothing but pp dollar ppp. Okay, pp dollar ppp. Then the computed z values will be nothing but 0 1 0. This will be 2. This will be 2. This will be 2. I think z equals to p will also work. Yeah, I think z equals to p will also work because we are taking dollar as a separator. So if z value will never exceed 2. With zi value will never exceed the length of the pattern. So instead of zi greater than equals to p, you can take zi equals to p as well. Okay. Now, how we are computing this z value? That is one important part of this algorithm. So I will provide the link of the z function. This thing z function related article of CP algorithms. I have gone through this algorithm only, and here it is explained. But still, I will explain the gist of it. Okay. So the brute force way to solve this z algorithm or computing the z function is explained here. Brute force way is this. Okay, so we are initializing every value of z with 0. Okay, we are initializing every value with of z with 0, and we are taking an inside while loop while I plus zi less than n, and s of zi is matching with s of I plus zi. So what is happening? So let's say we have ppa and let's say we have ppb. Okay, so I think ppa and ppb. Okay, ppa and ppb. So let's say initially this of zi value, let's say we are at this index I. Initially zi value is 0. So we'll check that z of we'll check s of I plus zi, s of I plus zi with s of I. Okay. So p is matching with p, so we'll increment the value of zi by 1. Now zi will be 1. Okay, zi will be 1. So we'll check this p with I plus 1. So p and p are matching. So we'll increment the value of zi by 1 again. So now the value of zi is 2. Now s I plus zi is this one. Sorry, s I plus zi is this one, and s of zi is this one. So a is not equals to b. So that's why we are breaking. Now the last zi value will be nothing but 2. I hope you get it. Now this is the brute force solution, but for every index for every index we are incrementing the value of z. Now let's say we have a n times. Okay, let's say all same characters n times. Then for every value we are incrementing this by I times, n minus I times. So the overall time complexity will be order of n squared. So this is the brute force z algorithm computation will not help us because this will be order of n squared solution. So for that we have to modify the implementation. Okay, let me clear this part and let me come back again. So for that, for making it fast, from order of n square, the current brute force solution is order of n square. From order of n square, we have to make it order of n to work. Okay, order of n or n log n, but here it is solvable in order of n. For that, we have to take some segment. So that segment is L to R. Okay, we have to take some segment L to R and we have to maintain this segment. So what does it mean? That this S of L to R should match with s of 0 to r minus l. Okay, and r is maximum among all the possible values of r. Okay, so s of l to r is s of matching with s of 0 to r minus l. So that means that z of l is nothing but r minus l. So we can say that. Now for a given I, okay, for a given I, what are the possibilities? We have already computed L and R values, right? So one possibility is that I is greater than R, and another possibility is that I is less than equals to R. Okay, so if I is less than equals to R, let's come into this case first. So if I is less than equals to R means that I is in this range, S of L to R. So we can say that we can initialize Z of I value with Z of I minus L. Okay, if I is less than equals to R, then we can definitely do Zi equals to Z of I minus L. Now we can say that if we take I plus Z of I minus L, this could be greater than R. Okay, so if I is less than equals to R, right? But I plus Z of I minus L can be greater than R. So in that case, we have to initialize the value of Z of I by with minimum of Z of I minus L, Z of I minus L, comma, what is the length of the string from R to I. R to I length of this will be R minus I. So we have to initialize Zi with minimum of Z of I minus L, comma, R minus I. I hope you get it. But and the rest of the part will be same. The rest of the part will be our order of n solution. But we have to just initialize the value of Zi with a minimum of Z of I minus L and R minus I. Now after the computation, if I plus Zi, if I plus Zi is greater than R, then we will do L equals to I. We'll just modify the value of L and R, and we'll do R equals to I plus Zi. Okay, I hope you get it. Now how this algorithm is order of n, this is also mentioned here. Okay, asymptomatic behavior of the algorithm. I will provide the link of the this article in the comment section. You can check that out. But the main part of this algorithm is to just just compute Zi value as minimum of R minus I, comma Z of I minus L. Now let me explain this part again. So we are saying that it's a B let's say A B and A C. Okay, so we can say the previous L to R will be nothing but this. Okay, previous L to R will be nothing but this will be L and this will be R. Now when we are at I, this I, we can say definitely say that this is starting from okay, let me take some more clear example to make it understandable for you. Okay, so I have taken some wrong example because you can see here that we are doing this thing that Z of I equals to minimum R minus I, comma Z of I minus L only if I is less than R. Here I is greater than R, so we can't do that. So let's take one other example, which is let's say AAB, AAB, AAC. Okay, now when we are at this index, this I, the previous this is I. Let's say the previous I value will L value will be this, and R value will be this. Okay, previous L value will be this, and R value will be this, because this is matching with this entire range. So now I value is nothing but 0, 1, 2, 3, 4, 5. Okay, sorry. Let's take I as this one, I as this one. Okay, so now I value is 0, 1, 2, 3, 4, 5, 6. So I value is 6 and L value is 3. So Z of I minus L will be 3. Okay, Z of I minus L will be 3. So this value. So we are saying that this thing Z of I minus L, this is matching with this A, because we can say, right. So we will be initializing Z of I value with similar thing. Okay. I think I am making again another mistake somehow. Let me take it. No, right. I am not making any mistake. So here Z of L value will be nothing but 5, because this is matching A B A with matching with the prefix of length 5. Now we will try to set Z I value as a Z of 3, but here we have not checked this character, right? So that's why we have to take the minimum value of Z of I minus L, which is nothing but minimum of 5, comma what is r minus I? R minus I is nothing but of length 2. So we have to take minimum of 5 comma 2, which will be equals to 2. I hope you got my explanation. You can take other examples also, and you can go through how zi is getting set from set of L minus I and R minus I. So I will suggest you to read this entire article once and go through the brute force algorithm is quite straightforward. Just go through this L and R definition. Also go through the time complexity, how they are suggesting that the time complexity will be order of n and R value is getting implemented only once. Okay, so I will suggest you to go through the entire article and what are the implementations of the article again. And also, let's jump into the code now. You will understand how this Z algorithm is getting implemented. So here the compute Z function is here. Now we are taking A as length of S, and this part is same as here. I have just copied the code from this and used it here. So this part compute Z function is exactly same. Now we are taking ps as p plus dollar plus s. Now we are computing the Z function. Now for we are starting from m plus 1 and we are checking if zi greater than equals to m. But I have already explained that we can only take zi equals to length of p. Then we are incrementing the value of answer. So the problem is quite straightforward, and the time complexity of this is order of n plus n. If I will provide the link of the code and the article in the description box. If you have any doubt in any part of of the explanation, you can always ask in the comment section. I'll try to explain other string algorithms also here, uh, uh, along with the CSES problems. So please like the video and subscribe to the channel, and also share among your peers. Thank you.